All right. Afternoon all, morning all, I should say. Thank you for coming along to our second decarbonisation webinar, De-Risk Your Energy Future. In the first webinar, we spoke a little around efficiency and the early stages, I guess, from a decarbonisation perspective. Today, we're going to talk bigger picture around some strategy work. We're also going to talk about technologies around some deeper transition and fuel switch opportunities. Just before we kick into it though, a little bit of housekeeping. So the intention today is about a 45-minute presentation, Q&A towards the end. Feel free to flick any questions in the chat box below, or feel free to send them to me personally. Please keep microphones and cameras off. And yeah, as we said, I'll collect chat later on for you all, for questions for you all, I should say. But just before we get into the session proper, just 2 seconds on why we're doing this and I guess who we are. So today, my name's Jeff Smith. I'm one of the directors at DETA. I'm joined today by Glenn Schultz. He'll be speaking to you initially a little around the market more holistically. He's our head of business development in Australia. Joined by him is Eugene Robson. Eugene is one of our Melbourne-based senior engineers. He'll be talking about some of the more technical pieces, or technical opportunities, I should say, from a decarbonisation roadmap perspective. And a little about DETA, what we do and why we're here. Simplistically, we're here to remove 2 million tonnes of carbon emissions. That drives all of our growth, our aspirations, our projects, and we do that in lots of different ways. But simplistically, it's around, for us, strategy development, decarbonisation pathways, project development and implementation. So what we're talking about today, I guess we'll be leading on real examples that we are helping to deliver, and examples that we have seen from others in the market who we think are leaders and are doing wonderful decarbonisation things across Australasia. So that's the introduction from me. I'm going to pass over to Glenn to start giving you a bit of an overview of the last webinar and kind of start kicking into the bigger picture around Australia. Glenn.
Thank you very much, Jeff. Does everyone can hear me okay?
Sure can.
Sure, great. Okay, awesome. All right, welcome to webinar 2. Thank you for everyone turning up. I'm going to just keep an eye on the incoming guests as people coming in the next couple of minutes. I guess we're only 2 minutes past the starting date, so just have to excuse me if I have to just quickly let people in through the waiting room. So as Jeff mentioned, I'm going to probably over the next sort of 15 odd minutes, just going to go through a few different topics leading into Eugene. I'm going to hand over to Eugene, who's going to get a little bit more technical on what this webinar is about as far as big impact initiatives. But before we do that, in case people couldn't make the first one or haven't seen the recording, I'm going to just go through a quick review of webinar 1. On that point though, if you didn't manage to catch webinar 1 or you haven't managed to catch the recording, feel free to email me after this webinar and I will send you the webinar link that is saved. So no problem at all. For you to come back and look at that, just give me an email after. Okay, so moving right along. So the main points from webinar 1. So just a few things to go through here. So I think the first point was about the uncertainty in, sorry guys, someone coming in here. The uncertainty for the Australia's power generation infrastructure, so ultimately the NEM. And we discussed the fact that about 16 gigawatts of power generation is currently needing to be considered over the next 2 decades for either reinvestment or substantial change to its means of generation, because at the moment it's obviously very fossil fuel driven. So that's a little bit of a challenge for the NEM at this point in time. We also talked about fluctuating gas and electricity supply pricing and whether the expectation is for that to continue. And the reality is that that is what we're thinking with all forward indicators. Went through some of the information around spot pricing on the electrical front. We looked at scenarios in which electricity reached $5,000 a megawatt hour over various occasions. and obviously some of the financial politics that was going on around that, with certainly generating supplier companies holding back supply to access better pricing on the spot market. Looked at the latest ACCC NetPack pricing reports, where we looked at the forward prediction for over the next kind of 12 to 18 months, even expectations of reaching $60 odd a gigajoule for natural gas supply to the end users, which is a pretty serious increase. We're already seeing, certainly on sites that we're working with, upwards of 300 to 400% increases once contracts come off term. But as far as the ACCC is concerned, that's not the worst of it. We are seeing it reside, or the forward prediction is that for it to reside a little bit further down in around 2024, something like that, where it's potentially going to head back towards $30 odd a gigajoule. Whether there's 60 or the 30 is an exact price, I guess it's all just indicators. The reality is, I think that we kind of all need to live with is that the landscapes of $10 a gigajoule are kind of gone, really. So we need to consider that there is going to be a much more expensive gas supply requirement for our sites, and that needs to be considered financially. So I looked at also the Australian energy consumption, and the estimation is that there's around 350 petajoules of thermal energy used for heat. That is actually ripe for decarbonisation now, based on the technologies and the costing, the commercialisation of those technologies in the market at this particular point in time, which is a pretty substantial contribution to Australia's total energy consumption. There's obviously various funding support opportunities, mostly in New South Wales and Victoria at this particular stage, specifically for industry. Went through a little bit of that. Most of you who are in those states will probably already know about this. It's a much bigger topic. So if there is any particular questions on funding availability within the states, just feel free to email me after this, and we can help you and guide you in the right direction. But ultimately, going to the government websites gives you a lot of information around what kind of technologies are available for funding schemes. Talked a little bit about the new climate bill targets, which is being increased from 26% to 43% over 2005 levels to be achieved by 2030, which is a pretty serious increase. I had a look yesterday at where the swings are, and it's definitely largely positive. It's all indicators are certainly looking like that's going to pass through. End of August, we're expecting the next report on that. Off the back of that, once that actually reduction target is kind of put in stone or through the Senate, we would be expecting federal support, different kind of funding mechanisms for the states to start rolling out pretty shortly after that, and certainly some more focus on industry on what they can do to help support that reduction target in 2030 is not very long away. At that point, Eugene went through a little bit of the quick wins. So he talked about the basics that can account for up to 5% in kind of cost and emission savings. And the basics were really around kind of operational maturity, things like insulation, boiler tuning, simple things like trap maintenance and leaks, like air compressor leaks and things like that, which I'm sure was all part of everyone's preventative maintenance schemes at this point in time. And then Eugene went through a little bit of the heat recovery side of things. So upwards of 5 to 20% reduction opportunities that sit around things like boiler economizers, heat recovery from things like condensate return, compressed air, a little bit of refrigeration, that kind of thing. And obviously reviewed some case studies around hot water flow restrictions, refrigeration, heat recovery, and those kind of topics. So that's kind of the summary from webinar 1. Again, if you do want the recording for that, just let me know and I will gladly forward that on to you. Okay, so moving on now. So what the next topic is really to talk about is the reality of those really cheap kind of utilities that we've, been so long within industry kind of expected to have, the sub $10 a gigajoule for natural gas, coal pricing being relatively low, and electricity being on tap and at a fairly low price as well, is kind of going. That infrastructure landscape is ultimately changing. We look to kind of some of the more public releases around the place. There's, if anyone isn't aware of the Australian Alliance for Energy and Productivity, they put out a huge amount of work and again, publicly available documents on different ways to help decarbonize the Australian economy. They do a lot of webinars, different type of case studies that are really good information that I really encourage everyone to go and have a look at. One of their latest media releases was around the natural gas and manufacturing crisis, which was really going into the stability and the cost fluctuation that we're seeing around electricity and gas. We can look to also the Australian Government Department of Climate Change, Energy and Environment, who are releasing sort of documents pushing towards facility electrification and suggesting that electrification of process and of facilities where it's possible, technologically possible, is actually becoming a viable solution for the longer term. And more recently, referring to the Victorian gas substitution roadmap, looking forward to where they want to end up, which is basically a gas-free economy within the state by 2050, or a natural gas-free economy, I should say, where they're outlining, in order to do that, electrification is going to be a pretty major part of that achievement, along with biogas or biomethane coming in to supplement that, which you can see through the grey and the pink bars further on in that chart. So interestingly, in the blue and the dotted line, that's kind of projecting out hydrogen and gas power generation. And even in the hydrogen element, which is that kind of light blue color, that really that's not becoming even viable or even part of this plan for the next couple of decades. And obviously, as we discussed in the last webinar, there's still a lot of work that needs to be done around the commercialization of hydrogen, certainly when we get down into industry levels. Okay, just to lead on to that, I think it's time to kind of address the old elephant in the room, which is all that carbon tax. So I guess the question really becomes here is how long is Australia going to remain exempt from a carbon tax or some sort of ETS program? I'm not going to say that this is obviously coming or when it's coming. I mean, this really comes down to individual businesses kind of looking at their risk appetite moving forward for a potential carbon tax and what that's going to mean for their facilities. But what I can sort of show you is if we look at where a carbon tax or an ETS kind of already exists in the remaining parts of the world, you can kind of see from a first world perspective that Australia is lagging behind as far as having some sort of either ETS or carbon tax kind of program in place. If we look across the ditch to New Zealand, they're currently paying $87.15 per tonne as a carbon tax, with the Climate Change Commission suggesting that they should be raising the trigger pricing that once achieved over and above the credit allocations within that $87 network to about $171 a tonne. So there's certainly lots of examples where ETSs are in place and carbon taxes are in place, and certainly what that breeds is a lot more motivation for industry to taking active involvement in for carbon reduction projects. The other thing we can do is look to another report released by Oxford Economics, which looked at carbon abatement curves and at what point the carbon tax is needed to be to get the biggest impact of emission reductions across industry sectors. And that's what that chart's kind of projecting there. And what you can kind of see is when we're up around that $100 a tonne, you're seeing the largest global greenhouse gas impact across the wider span of those industry groups. Obviously, there's some big numbers showing at the right-hand end of the graph, and that's like where there really needs more investment into the technology to make it viable. And that's the prediction that by having a higher carbon tax, it would be drive more investment into those particular areas. So again, I guess it's up to your individual sites, so yourselves as managers of the business, on where you think carbon taxes are going to come into play. The only thing I would point out with that is if you do feel that carbon taxes is the writing on the wall, and that is something that is ultimately going to happen, that the projects and the program of works that need to complement to reducing those carbon emissions on your site, are a long-term play. The planning of it, the consulting, the engineering side of it all needs to happen a long time before the actual implementation and the impact on carbon reduction. So if that's the kind of thought pattern that your business is open to, then the starting of that planning cycle, my suggestion should be happening sooner rather than later. All right, so where to start? Really where to start is the production of a carbon reduction strategy, ultimately, or a carbon reduction roadmap, depending on how you like to terminalize it. There is a really good document that DETA Consulting has put out, which is completely free. You can go onto our website and download it, but it's a guide to how to start considering and creating a carbon roadmap. I just noticed someone's in the waiting room. Sorry about that. So that's something that you can go and download after this if you feel like that would be useful. So let's start at really why develop a carbon reduction strategy. I mean, there's really lots of reasons why, but a couple of the two main reasons in my view is I think we're past the point of arguing that climate change is real. We've gone past that. The IPCC issued a pretty damning report in 2019, which showed that emissions have continued to increase across all major greenhouse gas groups across the world. And when we look at that report, it was noted that about 34% of those total emissions came from the energy supply sectors, with about 24% coming from industry. So the reality is, if we want to live in a more viable and sustainable world, that action needs to happen. So as I mentioned, I think we're past that point, arguing that particular point. But from a business perspective, it just makes good business sense. Investors, consumers, employees for that matter, all want to work for sustainable organizations, which are both environmentally sustainable, but financially sustainable as well. It builds obviously business resilience. There's longer term reductions to business costs, improves credibility, it drives cultural innovation within the business, all sorts of reasons, right? So I think to me, they're the main 2 points why we want to start considering a carbon reduction strategy. And the key steps to that development, first step, we need to produce a carbon footprint if it hasn't already happened on your sites. So the first point is to understand across the 3 major emitting scopes where that carbon footprint is coming from. And then from there, you can start setting reasonable targets for that emission reduction. Then obviously the identification of those opportunities needs to come into play. Where are those technologies? Are they commercially viable at this point? Is there a waiting period that we need to go through before we can kind of implement things? And then obviously a review and assess kind of process at the back end of that. But really where you should end up is something like this, which is ultimately a program of works to support your decarbonisation strategy over the longer term. So step 1 was really what we tried to cover in webinar 1. It was about reducing the baseline. So any generation kind of plants or any fuel switches or any electrification investments could be made as reasonably as possible, i.e. the baseline has been reduced because we've done everything we can on site from an efficiency perspective. And then when we start thinking about those big capital projects, we only need to cover what, the remainder that's left at that point in time. So that's where step 2 comes into play. It's understood that at step 2, these bigger impact initiatives, we are talking higher capital, longer term investment planning strategies, but ultimately becomes the most impactful for those businesses wanting to remain viable over the longer term. And ultimately, this needs to all be part of your financial planning cycles in some form. And hopefully at the end of that program of works, you're looking at a kind of an investment pathway that looks something like this. So because with the right program of works and projects and technologies that's been selected for your business, then you should really start to see carbon emissions obviously decreasing over the longer term, which is the green dotted line that you can see on the chart. Obviously, cumulative investment capital is also increasing because at the end of the day, you have to put in some investment into this particular program of works, but so should the cumulative energy savings to offset that investment should also be increasing. So for me to summarize, at the end of the day, with the right projects selected, we believe that over the longer term, a decarbonisation program such as this should ultimately pay for itself over the longer term. So with that, I'm going to hand over now to Eugene, who's going to go through more of the technical granular stuff to support that. And I'll just point out before I hand over to Eugene, just as a reminder, if you do have questions for the Q&A at the end, please just put them into the chat. Jeff's facilitating that. So we'll come back and kind of try to answer them as much as possible at the end of the webinar. But until then, Eugene, I'm going to hand over to you, mate.
Great, thanks, Glenn. And yeah, since you're in charge of the slides, I'll just give you a prompt to step through them. That would be great.
No problem.
But yeah, look, thanks for the intro. And yeah, as Glenn has mentioned, my section is spending about sort of 25, 30 minutes just talking through some of these larger impact initiatives. Because obviously in the previous one was looking, the previous webinar, I should say, was considering some of those easier sort of housekeeping, energy efficiency type opportunities. And this is getting into more of the crunchier end, which is probably in that sort of medium to long-term time frame once those initial projects that are a bit less expensive and a bit easier to implement have been done. It's really around what's some of those final steps to take to get towards net zero. So where I'll start is, it is very tempting as an engineer to jump straight to the boiler house. So for quite a few of the industries that we work with, process heat is quite a large component of a footprint for carbon emissions. So whether that's, say, a milk powder dryer or a meat processing plant or a manufacturer with, say, smelting requirements, often those types of industries need a lot of heat. And with the exception of direct electric fired equipment, a lot of the heat is coming from some sort of boiler system, whether that's making steam or hot water or what have you. But when it comes to looking at a really broad decarbonisation strategy, it is quite essential to, rather than just assume the BAU will continue for some of the current equipment and operation, it's a good chance just to test the waters and see for that particular industry if there are any new technologies that could be coming down the pipeline within the next, say, 5 to 10 years, which would have a significant impact in reducing demand. But that would require generally some quite large capital investment for changing specific bits of the process out. But if there is, say, a renewal coming up for a particular asset, and it's 3 or 4 years away, rather than just considering a like-for-like replacement, if energy efficiency and thinking about decarbonisation is part of that assessment process, then that is a really great way for those end-of-life renewals for assets to include decarbonisation in the conversation, and at the same time get some of the benefits included on the slide, really around with that modern technology. It's likely there would be improved control systems, better data acquisition, and improved productivity and profitability for the company as well. So There will be a cost, but on the plus side, there are multiple benefits that aren't necessarily, say, just energy or just decarbonisation related. So as an example, I've just got a few on the next few slides here. So this particular one is specific to the pulp and paper industry. So the industrial way to make paper is basically the same as if you're a child, just with very, very large equipment at very high speeds. So there's a forming section where the wet pulp gets spread across the forming table. It then goes through and gets dewatered through a press section to squeeze out the excess moisture before it goes through a drying stage to evaporate the water off the sheet. These machines are around about 100 metres long in some cases, so they're really large bits of kit. But there are often opportunities which, say, the operators will be aware of and, say, site engineers, where there might be some mechanical or maintenance issues, or, say, a vendor comes along and offers a new solution, which, for example, could be a new and improved dewatering section. So if, in the pulp and paper process, if additional dewatering can occur before going into the dryer, then you're mechanically removing water with quite low energy input, which then means that you don't have to use as much steam to dry to the particular specification for that sheet. And likewise with, say, capacity upgrades and improving, say, the hood and airflow, there's a limit to what you can do on the current equipment. But if it is starting to be a bit old or sort of towards the end of life, then there can be some really good opportunities to improve both productivity and also reduce energy at the same time as well. Just another couple of examples. So the one on the left-hand side is specific to the meat processing sector. So as we mentioned in webinar 1, the meat processing industry requires quite a lot of hot water for sterilising the butcher's knives in between cuts. And that, for compliance, to make sure that sterilisation occurs, the water needs to be at 82 degrees. And for a large abattoir, that's a really big portion of their thermal load on site. So as opposed to just, say, putting in a heat pump or just putting in a different type of boiler, for example, it's a really good chance to question whether or not hot water should actually be used for that particular application. So for example, over in the UK, there is a company that's developing these UV knife sterilisers, which rather than water, it's basically just getting zapped with UV to kill the bacteria. And in about 10 seconds, the knife would be clean and able to be continued for use. So this is an example of basically a no water option. And if this was something that got rolled out across the meat industry for the right application, it won't suit all environments, but where some of the processing is a bit cleaner and there's less fouling, options like this are a fantastic way to reduce water use. And that will ultimately mean that there's less of that medium to high temperature heat required for site. The example on the right is a manufacturing example for a plastics manufacturer. Historically, plastic injection molding machines, which produce all sorts of things from bottle caps through to buckets, through to ice cream containers, you name it, there's a plastic injection mold for it. So they're really cool pieces of kit. But historically, the drive system was traditionally hydraulic, which compared to modern all-electric systems is less efficient. So this is another example where you can get some really good reductions in electricity use while improving performance, reliability, and productivity for those types of equipment when it comes up to either asset renewal or foresight expansion. And yeah, it's just that dual benefit there. And the final example I had around some major process changes that we have come across for some of our clients. And this one's quite specific to sites that require evaporation as part of the process. So, for example, evaporators are used in the milk powder industry to increase the concentration of milk prior to going through the dryer, because it's more efficient to do that step before using the steam air heated dryer. And another application is, say, in the sugar refining industry, where they've got evaporators as well to concentrate up the sugar solution before it goes and gets turned into crystals. On the left-hand side, this is fairly common for those types of industries that I've just mentioned, to have a thermal vapor recompression. So down the tall cylinder on the bottom left-hand side, there's the calandria or the vessel. And in order to draw a vacuum, there will typically be steam that is coming in in order to recompress those vapors. And that's providing the energy for the evaporation to occur. So on the left is basically steam powered. However, on the right-hand side, rather than using motive steam to recompress the vapors, you can instead use electricity. And this is done through a mechanical vapor recompression, either a turbo fan or a centrifugal fan. And this is can be used in cascade and also in series to gradually repressurize that vapor and ultimately shift load from the boiler onto an electric motor. And similar to a heat pump, you can get some really good efficiency gains from this through that heat upgrade process. So they're just some various examples where, before even looking at some of the boiler systems, where there are some opportunities for that higher capex expenditure while changing the process and having a good stepping stone on that decarb pathway that Glenn mentioned. Great, so the next section I just wanted to cover off was electricity supply. So we've talked about some of those larger process opportunities. This section is electricity, and then the final one will be around some process heat switching. So as you can see on the right-hand side, these are just some figures on the grid emissions factor by state that have been forecast from some projections from DETA. So this was back in October 2021, so still fairly recent. And I guess the immediate trend that's very apparent is that between 2020 and 2030, there are some significant reductions in the overall grid emissions factor across all the states. And that's purely down to investment in renewable generation, and in some cases, depending on the state, the retiring of existing fossil assets as well. But one of the things to note is that obviously while the trends are going in the right direction, even by 2030, states like Victoria, Queensland and New South Wales clustered up on the top side there. The emissions factor is still likely to be around that sort of 0.5 to kind of 0.6 range, which from an electrification perspective, if we are looking at electrifying process heat that is, say, being supplied by a natural gas fired boiler or a burner, then from an emissions perspective, we're still short because the grid electricity is actually going to have a higher emissions factor by a factor of 2 to 3 compared to directly burning natural gas on its own. And I guess the key reason for still having those reasonably high figures by 2030 is down the left-hand side is just an example of a gas-fired power station in Victoria, where there's still obviously going to be additional investment going into renewables and solar, but there's still going to be baseload generation required to provide the demand, which means that by 2030, moving into the next slide, in order to hit some green targets, it's likely that there'll need to be other types of supply coming online, which is quite site specific. So when it comes to renewable supply, there are really only 2 routes to go down. So the first route is on-site generation. And this is just looking at electricity. So in most cases, this would be solar PV systems. And in some cases, which I'll touch on later, if there is, say, anaerobic digestion available, then a combined heat and power system could be an avenue to generate some of the electricity for site, but it's unlikely to be able to provide your whole site load. The other option is going down and directly investing in some off-site green generation. And the typical plant for this would be a renewable power purchase agreement or a PPA. And that would be from a retailer or supplier where the particular project is specifically allocated, and there's a guarantee that the investment that's going into procuring that electricity is directly going towards that particular project to encourage additional investment in solar, wind, and in some cases hydro as well. So that's tackled the electricity part of the puzzle. And then the next few slides, I was just going to touch on some common fuel switching opportunities, mainly for process heat, looking at hot water and steam in particular. So in New Zealand, and we're starting to see a few more examples of some of these technologies over in Australia. But just going to touch on heat pumps, mainly for hot water production, both electrode and biomass boiler options, touch on biogas as well, and then a bit of a taster for some other technologies that are coming along down the pipeline that have some really good potential, but are still either site specific or in that development stage as well. So hopefully everyone on the call knows that high temperature heat pumps are wonderful things for hot water. So if you don't, then you can have it as the key takeaway today. Look, generally they're really good for producing hot water between 40 to 80 degrees. And in particular for, say, food and beverage type applications where there's cleaning involved, there's washing, or it's used directly in the process, then this can be a really good way to decarbonize a say, a gas-fired hot water heating system. In order to make the system efficient and to help reduce the capital cost, ideally the heat pump would be supplementary to an existing refrigeration plant, which could either be, say, a chiller or a freezer plant. And the reason for that is the refrigeration systems are giving off a lot of heat to atmosphere through the cooling towers. So rather than rejecting that heat to atmosphere, a heat pump is effectively adding an additional stage on top of the current high stage. So it's using the waste heat and then upgrading that to up to 80 degrees for this hot water example. And it's doing that very efficiently because the starting temperature for the heat source that it's drawing it from is already at that, say, 25 to 30 degrees. And because it's drawing it from refrigerant, you're not having to install really large air coils for, say, a direct air system. So with the benefit of an existing refrigeration plant, the coefficient of performance is around that sort of 2 to 3 mark, but it is quite specific depending on what your available heat source is, and then what your heat load is as well. So it can be higher and it can be a little bit lower, just depending on it. But ultimately, because it's above 1, we're getting more efficiency compared to, say, a boiler system, which would have an efficiency of, say, 85%, for example, whereas with these, you're at that 200 to 300%. So we're getting more heating out than the electricity that we're putting in. And just an example of this is for the Alliance meat processing site. So this one's a New Zealand example, but they had a requirement for a diesel boiler. So they had a 1.2 meg boiler on site. For them, diesel was an expensive fuel source. And because they had chillers and blast freezers on site, DETA initially did an energy audit and identified that a high temperature heat pump would be a really economic option. And then we went through a business development stage with them to get it fully scoped and priced. The installation was done, and that system is now, or has been running for over a year now, and is performing really well and has reduced the diesel use on site by 90%. So it's a really good success story for Alliance, and there's a great case study and interview on the A2P website as one of the webinars. So for more information, yes, just checking that out. Next up for alternative steam options is electrode boilers. So these have a variety of benefits, but also some drawbacks to be aware of. But if you're able to source green power to go into them, then they can be a fantastic way to decarbonise a site using existing technology that's available. So the electrode boilers are high pressure, so 10 bar and up, they don't have any issues with it. And from an efficiency perspective, because there's no direct combustion of gases and having to draw in air for an existing, say, natural gas boiler or a coal boiler, you don't have any efficiency losses from the heating process. It's just the losses from hot pipe work, etc., around the boiler itself. So the combustion efficiency for these boilers is actually 100%, which is pretty jolly good, as opposed to that 85-ish% for, say, a gas-fired boiler system. One of the other benefits is that they are quite compact. So they're basically giant kettles, so large, tall cylinders. And because they're in a vertical orientation, the actual footprint required for them is not particularly high. And this is a benefit for existing sites, which may have some space constraints, where if there's a current boiler house, then it's possible that these would be able to get included into the current one or added onto the side. Whereas when it comes to, say, biomass boilers, they're much larger, so do take up a lot more space compared to an electrode boiler. And just as an example, so this one is also one from New Zealand. So there's the Mataura Valley Milk Company, which is based down in Southland, and they already had a coal boiler on site that was at 40 bar, and in the image on the right hand side you can see the large coal stack over on the side there. That was already there, and through their decarbonisation strategy they have decided to go through and install a 15 megawatt electrode boiler, which is a pretty impressive project. And that for them, coal's very cheap. So the electrode boiler, given that it's going to be using grid electricity, there'll actually be a premium paid for that power compared to with coal. But because it aligns with their sustainability targets and there's product quality benefits as well, then for them that was the pathway that they've decided to go down, which is really bold. And they are going to keep the existing coal boiler asset available, but they are looking to supplement it with biomass, and that will allow them, when there's not much hydro around, the retailer will use them to basically shed load. So they'll switch off the electrode boiler and they can bring the existing one back on site for, say, a few week windows and then shut it back down again. So there's a good financial benefit to keeping the current boiler asset available. Rolling into biomass boilers. So this is another renewable option for steam generation. So there's heaps of examples of these over in Europe, and then some in New Zealand and also in Australia as well. One of the things with biomass is it is quite location specific. So what I mean by that is, depending on what resources are available either near to the site or co-located, it could either be a really good option or it could be quite a poor one if there's large transport distances involved. And typically, if it is, say, a waste product, so if that's, say, offcuts or sander dust or hog slash from forestry, then that's a cheaper fuel source as opposed to, say, like pulp chips, which are a lot more expensive. So the other slight drawback with biomass is, obviously, compared to, say, coal, the energy density is much lower. If you are looking at pellets, which are a bit drier, then you're up around the 17 megajoules per kg. But for coal, on average, is about 24. There's a bit of a penalty there with the energy content. And that just means that the number of truck movements to get that material to site is a bit higher. And that does need to be factored in as part of the design as well. The fuel handling and feed systems are also take up quite a bit of space. So that's just something to consider. And this image here just shows those large volumes of chip stored out on site. And just a couple of examples here. So on the left-hand side, this one's from Casino in New South Wales. So that's the Northern Meat Co-op. And for them, back in 2018, they went through and invested in biomass. And for them, that's from sawdust and macadamia. So that's obviously close to their current operation. And then on the right-hand side, a couple of examples from New Zealand. So one of which is Fonterra Te Awamutu, and this was converting an existing coal-fired boiler over to wood pellets. And Fonterra have also recently announced that they're going to convert another site to wood biomass. That's a brand new boiler, and that one's 30 megawatts. So both of those are quite large, chunky examples of that biomass.
Hey, Eugene, it's maybe 5 minutes to go, if that's okay.
Sorry, what was that? Sorry, Jeff?
Sorry, just maybe 5 minutes to go. It's 10 to 12.
Yeah, sure. Want to make sure we've got some time for questions. So, look, I've just got 3 slides left, so I will get through here. Yeah, I'll just speed up a little bit for these last couple. Yeah, so the last one I wanted to touch on was anaerobic digestion. So this, similar to biomass, these are obviously quite specific to particular sites. But basically, if there's a site that has got an organic waste stream available, so that could be from, say, animal manure or some sort of other organic material, then a couple of applications that we've seen would be around, say, a covered anaerobic lagoon or a digester. So a couple of photos on the right-hand side there. And from a recent report from 2017, there were almost 100 of these systems installed across Australia. And this is a great way to reduce waste, but also to generate either just straight heat, if it's going into a boiler system, or for a combined heat and power application as well. And then finally, on the next slide, there are also a wide variety of alternative and, well, not alternative, but other options and technologies which definitely have very good potential depending on how the technology develops and also some of the economics too. So just on the slide here are a few examples, and the plan is in webinar 3 is we'll go through these in a bit more detail and have a few examples and case studies. But just as a bit of a teaser, we'll be looking forward to talking through some of these options with you as well in the next one. And just finally, I won't go through this in detail, but there is just a summary here of a variety of different common processes on the left. So around, say, steam, hot water, and a few other specific processes, and then some possible technologies that may or may not be suitable, but should be investigated to determine how the economics look and what's best for your site. So look, that's all I had. I appreciate we've only got a few minutes to go, so I'll stop there and yeah, hand back to you, Jeff, for any Q&A. Thank you.
Thanks, Eugene, and thanks, Glenn, for that overview. As you can see, there's lots of content to cover, so the 45 minutes blew out a little bit, but we're going to have 2 questions, if that's okay. I'm going to ask one, which is really, we talked about lots of technology, and I guess the question for you is, what makes sense now? Economically, you talked about electrode boilers being challenging. Does any of this stuff reduce cost when you're talking about fuel switching?
Yeah, it's a good question. So I guess going back to the whole pathway, the stuff that makes good economic sense currently are all of the smaller low-hanging fruit around efficiency and heat recovery, give really good paybacks. Some of these options, depending on the price of electricity, and with more renewable electricity coming online, the prices would hopefully be a bit more separated from the gas market, so we should see a decline there. So longer term, it will be good, but at the moment, there are some challenges around doing an immediate switch to, say, a full electrode boiler. not only from the operating cost, but also the capital cost for that infrastructure can be quite high as well. So it's not necessarily around, there's no magic bullet, I guess, for immediate changes, but it's more thinking around, look, as we look at these options, what are some ones to consider, and at what stage would some of those decisions start to be made along that sort of 10-year journey?
Sure. No, appreciate that. The no silver bullet thing is very valid. Final one, bonjour, Francois. Thank you for your question. You talk about biomass, and I guess from a DETA perspective, we've done quite a lot of work on biomass here in New Zealand, where we're looking at the available quanta that we could possibly burn and use to replace process heat. What does that market look like in Australia? Can you shed any light on the real availability of biomass, and is it going to provide a lot of the conversion that Australia requires?
Yeah, that's another good question. So it is specific depending on where in Australia you are. So there are still some large forestry blocks available where, say, for slash material is easy to obtain. The challenge comes down to transport distances from where forestry is located to where the site is. So, and that's also where if there's co-location, so if you're near to some of those resources, or in the husk or the nut example, if you're close next door to operations like that, it makes sense. But for most sites, it is going to be probably down the electrification route, as opposed to the biomass route. But once again, it's horses for courses.
Perfect. Thank you. Guys, that's all we have time for today, but we really appreciate you coming along to our second webinar. As Eugene alluded to, there will be a third webinar where we're going to drill down a little more into some of those future opportunities that may be coming, rather than the what's here right now. And again, trying to paint a picture of what 2025 and 2030 might look like. But for now, thank you for attending. This has been recorded and will be available if you require online. But I hope you enjoy the rest of your day, and thank you for coming along.
Thank you, everyone.